In this next video, we're going to discuss what are referred to in general as formula weights. And then depending on whether we're talking about an ionic compound, such as calcium chloride here, or a molecular compound or a molecule, we refer to these as either formula weights for ionic compounds or molecular weights when we're talking about molecules. So again, an ionic compound is composed of a metal and a nonmetal, and then a molecule is all nonmetals that have combined. So things like carbon, hydrogen, oxygen. So let's take a look at how we could find our molecular weight for calcium chloride. So first we'll need to find the molecular formula or the chemical formula. In this case, the formula unit for just one repeat of calcium and chlorine when they combine. And because we know that ionic compounds are crystals that have many of these repeat units. So calcium, if you recall, is in group 2. It would form a +2 metal ion. Chloride's in group 7. It forms a -1. If we were to crisscross these charges, we're going to see the calcium chloride would be CaCl2. So now to find the molecular weight, I need 1 calcium, and I go to my periodic table, and that's 40.08, either atomic mass units, or we'll see another unit of gram per mole that we can use interchangeably. And then we need chlorine, and we need 2 of those, each of which is 35.45 AMU or gram per mole. So we will add the sum of these together. So we'll add 40.08 plus 70.9, and that will give us the formula weight for this compound. Calcium chloride is 110.98 AMU or gram per mole. So let's look at the same process, but with a molecular compound. So something like C2H6, for example, has only nonmetals combined. And I have carbon and hydrogen. I have 2 and 6. I go to the periodic table. Each carbon is 12.01 AMU or gram per mole. Each oxygen we can round to, oh, not 1.08, 1.01 from 1.008. So here we have to just 2 decimal places, and we'll get 24.02 and 6.06. So we add these together, and we would see that the molar mass or C2H6 would be 30.08 AMU. So we can try this again here with this sample exercise. So we have sucrose, which, if you did not know, is table sugar. It has this molecular formula here. So let me write out all of my elements. I have 12 carbons, 22 hydrogens, 11 oxygen. I go to the periodic table to get their masses, and I remember 12.01 for carbon, 1.01 for hydrogen, and then oxygen, generally, we just round to 16. It's usually 15.999 on the periodic table, so you can see why. We find the product of each of these, and then we add them all together. And we should end up finding sucrose's molar mass to be 342.34 AMU. We can do this again for another ionic compound shown here. So we have calcium, and I only see 1 of those in my compound, but I see 2 of this nitrate polyatomic ion. So I have to distribute that 2 to say that I have 2 nitrogens, and then the oxygens, I have 2 times 3 or 6. So once again, I'm going to go to my periodic table, get these masses. Nitrogen is 14.01, oxygen 16. So I find the products of these, and then when I add them all together, I would have 40.08 plus 28.02 plus 16 times 6 is 96, or 164.10 AMU. And notice when I Added them all together, I retained 2 decimal places here for the oxygen as well. So there's one last topic that I'd like to discuss in this video. It's something called percent composition. And if you can find the mass of each element within your compound, if you wanted to find the percent composition of a certain element, you would just divide the molar mass of that compound by the mass of the individual atom. For example, in our previous C2H6, we found the molar mass of the entire compound was 30.08. But say I wanted to know the percent carbon in this compound, I would just take the mass of the 2 carbons, so 2 times 12.01 or 24.02. And I would divide that by 30.08. And I would find that the percent mass of just the carbon in my compound is about 79.9%. So this is called percent composition. And again, it determines or tells us the mass of a single element within a compound.